This eliminates the need for that catalytic converter, and essentially the rest of the changes to the engine are minor, and something that wouldn't done at the factory would basically have little or no cost differential from a conventional engine. So consequently, you have a better performing engine for less total dollars, and it will be a cleaner engine as well. Zero Fuel also has several other markets besides cars. As a matter of fact, there's excellent opportunities in heavy machinery, equipment, trucks, mining equipment, construction equipment. It's well known, if you're in the construction industry, for instance, to run a bulldozer all day is like running 500 cars, and they have the fuel bills to prove it. So if you could save money on that fuel bill, that is a big advantage. Another big advantage is that right now the EPA is starting to crack down on the emissions of a lot of these diesel engines, and it's a big problem for both the diesel manufacturers and the construction industry. The construction industry, people don't want to commit to buying a piece of equipment that normally would last 10 or 20 years if the EPA is going to change the rules in 3. So they end up wanting to lease the equipment, but that's not good for the manufacturers, because what do they do with the leases? So they need a clean fuel. Urea will be that clean fuel. That clean fuel, if used in place of diesel fuel, would obviate all the emissions problems that the heavy equipment has. This is a huge market. It's a very important market. It is a large source of pollution that could be eliminated by switching to the urea. Another thing is that in heavy equipment, there is, again, just like in traveling, there's the danger that you're working around dangerous areas. You prefer to have a fuel that's not flammable in the case of any kind of accident. The accidents are bad enough, they don't need to add fire to it. Again, the fact that urea is not flammable would also be an excellent safety issue as well. Okay, we're going to show you how simple it is to make some zero fuel. First of all, the key ingredient in the fuel is urea. As you can see, we just buy 50-pound bags of the urea, and as a matter of fact, we just scoop it out, and you can see it's just these white prills, and very safe material, non-toxic, nothing to worry about. And normally I would measure and weigh this, but to show you how simple it is, we're just going to take some water from here. I know I'm blocking. So we just take some warm water, and essentially all you have to do is just pour it in here with some stirring. As you can see, just like dissolving sugar in water, it just takes a minute. And there you have it. And it just looks like clear water. And as a matter of fact, then this is what actually goes in the gas tank of the car. And essentially, when you need the fuel pump pumps it over this catalyst right here. This catalyst turns it into ammonia, and the ammonia is what's burned in the engine. And it's as simple as that. It's safe, it's clean, and it's cheap.
We're here at Bayshore Recycling to do an experiment, and the experiment is to make a 1-liter engine run on ammonia as a fuel instead of gasoline or diesel. This machine here is the device that we use to generate the ammonia. If we go through the sequence of events, this plastic container contains 50% urea and 50% water mixed together. Is it attached to a pump? The pump feeds this line into this bonnet of steel. Inside this reactor vessel is a coil of stainless steel tubing attached to a reformer. Inside the reformer is a proprietary metal that we use to turn the urea into ammonia. That runs through here, and if you notice down here we have a heat gun which will simulate the exhaust of the engine when we build this into the car. This heat gun gets to about the same temperature as the exhaust, so we use this to generate enough heat to simulate the exhaust going through the exhaust pipe out to the back end of the car. When it gets up to a certain temperature, the urea is turned into ammonia. It comes out of this tube into this check valve into these storage tanks. The storage tanks hold the ammonia until we're ready to use it. After we reach a certain pressure and temperature, we inserted this plastic tube into the intake of the fuel injection system, which is where the air goes into the system, not the fuel itself.
Fill the car.
Yeah, you roll it?
And then I'll work off your cue.
Okay, turn it over. Running on ammonia. The car's running on ammonia. We're losing pressure pretty quickly. Got the valve all the way open.
Timing all the way in.
It did run on ammonia, so we proved the point.
That's it. We got that. It started on ammonia, which is the high side.
Yeah. Cut the pressure.
Gas off?
Gas is off.
Alright. Just want to see something. Just want to make sure it was going to completely run out of fuel, you know what I mean? Alright, and we'll do a run test and then we'll see how far.
50 pounds.
Is that a lot? The mic? Maybe? Is that right? What did we get? Then on the third test, if we did actually achieve a run from an idle, we wanted to give it some air and see if we pick up RPMs.
Okay. We're out of fuel.
Alright.
Oh, it didn't work now.
Yeah, it worked. Started right up. Settles that.
You got it. You got it.
That's it. Yep.
Excellent. Thank you. We were able to run the car, the engine, the 1 liter engine, and accelerate it at the same time for about 30 seconds, something like that. And that is basically the function of this machine and the simplicity of it.
Bayshore has devoted its garage and engine lab space to alternative fuel sciences. Currently, we have 20 mechanics and engine specialists on our research team. These individuals already manage, repair, and operate our fleet of 60 vehicles and 165 pieces of heavy equipment. It is our goal to begin the conversion of all of these vehicles and equipment to zero fuel by next year. Together with our inventor, partners, investors, and developers, we believe that zero fuel represents a great opportunity to make cars and trucks run completely clean, but with the convenience and performance that society demands and at a cost that enables it to be implemented in 2010. AFS and Zero Fuel are especially interesting to Bayshore Recycling's founders, the Monte Calvo family. As you will see from our collection of cars, boats, and other motor vehicles, we have racing in our blood. AFS and Zero Fuel technology are very much the intersection of vehicle performance and the green movement. Zero Fuel and its derivative ammonia gas have more octane than gasoline, uses existing engines, produces zero emissions, and is less expensive than diesel fuel. And most importantly, it's viable today. We will devote our time, know-how, contacts, capital, and other valuable resources to ensure the absolute success of this noteworthy project.